solve the difference equation yk plus 2 plus y of k equal to 1. Initial conditions are y of 0 is equal to y of 1 equal to 0. Given that y of k plus 2 plus y of k is equal to 1. So we are writing in the standard form. So yk plus 2 plus yk is equal to 1. That are same. Because of our convenience, we are writing this one, right? Taking z transformation on both sides, z of y of k plus 2 plus z of y of k, that is equal to z of 1. We know z of 1 which is equal to z by z minus 1. And zy k plus 2, zy k, we know the formulas, we are substituting all those things. So z square into f of z minus z square into y0 minus z y1 plus f of z which is equal to z by z minus 1. Since the formula for z y k2 k plus 2 is z square into f of z minus y0 minus y1 by z. So that is the formula. Multiplying with z square, you will get the first three terms in the first line, right? Then z of y of k is nothing but f of z, and z of 1 on the right hand side z by z minus 1, right? Given that y of 0, that is y0, y of 0 that is equal to 0, and y1 that is y of 1 is equal to 0. So substituting those values, z square into f of z, y0 0, second term 0, y1 0, third term 0, plus f of z which is equal to z by z minus 1. So f of z is common, grouping that z square plus 1 into f of z is equal to z by z minus 1. Therefore f of z which is equal to z by z minus 1 into z square plus 1. Right? Now we need to find y of k. Right? F of z which is equal to z of y of k is equal to z by z minus 1 into z square plus 1. So to find y of k, that is taking inverse, right? Inverse transformation of z. So we are using the residue method. So by residue method, we need to find f of z into z power k minus 1 first. So multiplying z power k minus 1 on both sides, so you will get f of z into z power k minus 1 which is equal to z power k minus 1 into z by z minus 1 into z square plus 1. Grouping z power k minus 1 into z, you will get z power k, right? Z power k minus 1 into z which is equal to z power k minus 1 plus 1. Minus 1 plus 1 get cancelled, so you will get z power k by z minus 1 into z square plus 1. So we need to find the pole of f of z power k minus 1. That is nothing but taking the denominator of the right hand side equal to 0. So z minus 1 into z square plus 1 equal to 0 means z is equal to z minus 1 equal to 0 or z square plus 1 equal to 0. So z minus 1 equal to 0 means z is equal to 1 is a pole of simple order. A simple pole, that is order 1. And z square plus 1 equal to 0 means z square equal to minus 1. That is z equal to root of plus or minus root of minus 1. So it is equal to plus or minus root minus 1, we know I, plus or minus I. So z is equal to plus I, z is equal to minus I are simple poles, right? So we will get total 3 poles, all are simple poles, right? So first we need to find residue 1 R1 which is equal to residue of f of z power k minus 1 z equal to a. So first one for the simple pole formula which is equal to limit z tends to a z minus a into f of z into z power k minus 1. So substituting a is equal to minus 1. So limit z tends to minus 1 z minus z equal to 1. Substituting a is equal to plus 1 1, not minus 1. So z tends to a z minus 1 into z power k z minus 1 into z square plus 1. So z minus 1 in the numerator, z minus 1 in the denominator get cancelled. So which is equal to limit z tends to 1 z power k by z square plus 1. Substituting the limit 1 power k by 1 square plus 1. So 1 by 2. That is R1. Now R2. Now taking A is equal to I. Right? So limit Z tends to I, Z minus I into Z power k by Z minus 1 into Z square plus 1. So splitting Z square plus 1 using A square minus B square formula. That is Z square minus 1. Minus 1 can be written as I square. So Z square minus I square. So using A square minus B square formula or factorizing Z square plus 1, right? In Z plus I into Z minus I. That's all, simple, right? So factorizing. So Z minus I in the numerator and Z minus I in the denominator get cancelled. So limit Z tends to I, Z power k by Z minus 1 into Z plus I. Substituting the limit I power k by I minus 1 I plus I, that is 2I. So 2I into multiplying the conjugate of minus 1 plus I, that is minus 1 minus I, and divided by the conjugate minus 1 minus I, right? So minus I into, right, because we have I in the denominator, right, and minus 1 plus I in the denominator, right? So first we are multiplying the conjugate and divided by the conjugate of minus 1 plus I. Similarly, we have to multiply the numerator by the conjugate of I. What is the conjugate of I? Minus I. So we have to multiply by minus I and divided by minus I, right? So you will get minus I into minus 1 minus I into I power k divided by 2 into I square into I square minus 1. So minus 2 into 1. Then here minus 1 square plus, minus I square. So minus 1 square 1, then I square plus minus of minus 1 plus 1, right? So minus I minus 1 minus I power k 2 into 1 plus 1, right? Because 1 by I is equal to nothing but minus I. You can take it like that, right? So because we are multiplying minus I in the numerator by minus I in the denominator. So what happened? That is what I told. I into minus I square plus 1, right? So I power k I minus 1 by 4. So I square equal to minus 1. We are taking that value. So that is R2 which is equal to 1 by 4 minus 1 plus I power k. Now R3. So replace I by minus I here. So R3 is equal to 1 by 4 minus 1 minus I power k, right? So we know yk which is equal to sum of the residue by the residue method. So R1 plus R2 plus R3. So we will get 1 by 2 plus 1 by 2 minus I plus I power k plus 1 by 4 minus 1 minus I power k. That is what the solution of the given